So I'm Tim Malalu. I presume everybody can hear me? I can't see Jack right now. I think it might be interesting to give you a little bit of context on how this talk came about, why we decided to do this talk, and hopefully you'll get something interesting out of it. So as I said, my name's Tim Malalu, and if you had seen that the talk was originally Tim Malalu and Lara Rubelki. And I'll say that a few months ago, Lara and I were having an email exchange, and for people who don't know, I've been trying to get Lara to come work with me on my team for quite a while now. And so whenever Lara emails me, she's like the first person that I respond. If you guys don't know who Lara was, she was in Scott Gu's keynote. Amazing person, great person that everybody would want on their team. So as soon as she emails me, I'm responding, oh, it's Lara, I gotta give her like the utmost attention. And she goes, hey, you wanna do a build talk? I'm like, last time I did a talk like that, it was at PDC, and it was on Entity Framework when I was on the Entity Framework team. It was a little while ago. Sure, what's the talk about? And she said, well, I want somebody who's not on the SQL DW, SQL Data Warehousing team, or on the Azure Data Lake team to come up and give a neutral perspective, very customer-centric perspective on this simple question that we always hear, which is when to use what, why do I have to do this, why do I care? And so I said, yeah, sure, why not? Sounds like fun. And then at that time, I'm thinking that Lara and I are going to do it together. And then a couple months go by, and I'm in the hospital because I'm just come out of surgery. I had hip surgery 7 weeks ago. So I'm literally in the recovery room, and the worst thing to have in the recovery room is a phone. Because all of a sudden you can do email, right? And so I'm in the recovery room. My wife's next to me. She's like, you okay? I'm like, yeah, I'm good. I can't feel my legs yet. And the pain meds haven't completely worked off. But there's an email from Lara. Let me see what it says. And Lara says, this is the abstract. This is totally what we should do. We should come here and talk about ADLS, Azure Data Lake, and Azure Data Warehouse. And I'm not very good. I always say SQL Data Warehouse, but I guess the real term is Azure Data Warehouse. And we should totally do this together. So I said, yep, book it. I'm in. Let's do it. And then Lara has this little thing because Scott Guthrie wants her to be in the keynote. She's a little busy. She's driving a whole bunch of the talks. In fact, I think a lot of the talks that came out of Joseph Sorocha's org, she was kind of instrumental in driving and getting them together. And so what she did was she collaborated with me, and we put the talk together, and so hopefully you'll have fun with it. But she's taken the seat right at the front so that she can heckle. So anyway, so in all seriousness, I was really excited to do the talk. One, because I wanted to do it with Lara, and one of these days we'll actually do a talk together. But two, because I think it's one of the most common questions that I hear on the data side of the world right now, which is, hey, this Azure Data Lake thing, what is that? How does that relate to the concept of a data lake in the public and blah, blah, blah? Hey, you've got an Azure Data Warehouse thing. When do I use Azure Data Warehouse if I can do these data warehouse style queries on Azure Data Lake? I don't get it. And I haven't really said what I do in Microsoft, but I've been at Microsoft for much longer than I thought I would be. And now I don't see myself ever leaving Microsoft. But I've done a bunch of things in the product teams, and over the last 2 years, I'm still in the engineering organization within Scott Guthrie's organization, but I run a set of solution architecture teams that work with customers on end-to-end scenarios across kind of all of Azure. And so we have a team that's been doing a bunch of stuff in IoT. We have been a team that's been doing stuff in kind of PaaS v2 and thinking about how you do modern architectures on Service Fabric and stuff like that. I have a team that does big data and analytics, and a recurring theme across many of the scenarios, whether you're doing an IoT scenario or whether you're focusing on big data and analytics, you end up getting to this place where you have to go worry about the data. And nowadays, worrying about the data can mean a whole bunch of things. It could mean worrying about streaming data. It could be worrying about on-premises data and old ETL processes that you used to have in on premises that you want to move to the cloud. It can mean all kinds of things. And so it turns out this really is a very common ask that we get from people. So the nature of today's talk will be, I'm going to use examples from a bunch of customer projects that we've done over the last 6 months. I shall not use names to protect the innocent. But I'm going to take you on a little bit of journey on what we've been seeing across a set of scenarios, and hopefully that will help answer the question. And feel free to come slap me if I made it even more confusing. OK, so first of all, just as a show of hands, how many people here think of themselves as a data person as opposed to a dev? Yeah, this is funny, right? Show of hands that I can't see. Let's see if this will work. No, it doesn't work. All right. Show of hands over here. Handful. Over here? OK. How many of you guys consider yourselves developers as opposed to data folks? All right, great. How many of you guys know what the Lambda architecture is today and think about data patterns in the cloud using things like the Lambda architecture? OK. How many of you guys are actually trying to do data warehousing projects in the cloud today? OK. So one of the things, the reason I ask this is that I'm going to go through a bunch of stuff that we've been playing in the big data space that's related to data warehousing and to big data scenarios in general. And people can get confused by some of the things that I'm saying and say, hey, he's doing the Lambda architecture. We're actually going to separate the concerns, and we're going to talk about the different components, whether you're doing this in a streaming layer, whether you're doing this in a batch layer, whether it's just to serve up something for an operational analytics, or whether it's to serve up your financials for a month-end close. What we've seen is that we can actually decompose the problem, and we can start looking at the problem in a way that is, it broadens the applicability. It also broadens the choices that you have across the space. And the problem that we had in the past when devs or data devs or however people identify themselves, I've been slapped because apparently people get very sensitive about titles and stuff. But when they used to think about a lot of this, they would do it in a simple way, either ETL or ELT. They'd shove a bunch of stuff in a relational database. They would use stored procedures or SQL scripts to process in the database. Or they would use something like Informatica on the outside, and they would, or SSIS, yes, Microsoft's products too, so that they could actually do a bunch of processing and data flow outside of the database, right? The problem with that, when we start thinking about the new sets of requirements that people have, is that there's no clear separation of concerns. People would talk about ETL, extract, transform, load, or they would talk about ELT, extract, load, transform. And the funny thing is, I'd be sitting down with people telling me about this, and they'd be using the same tools. And they weren't thinking about, how do I think about this part of the problem? How do I think about this part of the problem? What is the best tool for each of these? And so today what we're going to do is separate the concerns. Instead of talking about just ETL and data warehousing, we're actually going to talk about how we think about the problem at a more fine-grained level, and then how they actually compose. So the way I'm going to separate it is I'm actually going to talk about ingestion, processing, staging, and serving. And this is the logical progression. It turns out that I invert that in the deck on purpose. But a guy walks in a bar and says, I want to do some data warehousing. And the bartender says, all right, where's your data? Well, you got to get some data. You got to shove it somewhere. Then you got to do some curation on that data. That's the processing. And then you're going to do that curation, and you're going to shove it somewhere else. And when you shove it there, you're going to think about the security aspects of it. You're going to think about, what summaries of that data do you want people to see. And once you've sorted out that, you're going to serve it up to the public or to your consumers so that they can share it. And so when we think about the different aspects of data processing, whether you're an app dev, whether you're an analytics person or somebody, or a data scientist or what have you, what we like to do now is break it into the notions of ingestion, processing, and the different types of processing you can do there, staging, and serving. Now, my favorite scenario for today, and I'll keep on referring to it, is an internal project that we've been doing at Microsoft. And I can't say what the system is, but let's say that there's a system that's over 2 decades old at Microsoft that we're moving into the cloud. And that system grew in a relational database as Microsoft grew. Today on premises, that system uses I think it's like a 96-core, 4 terabyte, scale-up SQL data warehouse to do a whole bunch of ETL processing. They've got millions of lines of quote-unquote business logic in SQL stored procedures. And they have a batch window where they do that processing that I think is about 14 hours. And every 12 or so months, they have to go buy more hardware. And the reason they buy more hardware is because the rate of data coming in is increasing so much that their batch window to process that data is exceeding the SLA they need for the consumers of that data. And so what we've been doing with that team is we've been looking at how you would move that into the cloud. We've been looking at what would be the ingestion patterns. Oh, gee, you're scaling up in SQL Server to do all your data processing. Are there ways that you can scale out? If you're going to scale out, should you use a big data approach? Should you use C# across a sea of VMs, which is pretty cool, and I'll talk about that. I tend to be biased to that one, and you'll see why. Should you use Azure SQL Data Warehouse and do a massively parallel SQL solution as opposed to an imperative solution in C# or a big data solution using something like Spark or uSQL? So there's the choice about processing. And then the staging. Imagine that you did a whole bunch of curation and you're in the cloud where you want to push that somewhere so that you can start serving that up for other people. So there's a notion of putting that data to a place where there could be other processing or consumption on top of that data. And then from that, there's a serving piece. And that's how you actually serve it up. And then serving becomes interesting in and of itself because of the different requirements for how you want people to actually consume that data. There's a term that I'm going to use a lot today, and it's called observational latency. And actually, by the way, here's the funny thing. If you think I'm just nervously pacing, there's 2 things. I got one of these, the band, and my wife's in LA. We were down there all week doing college tours for my kid. I can't believe that my kid's old enough that we were looking at college tours. I remember when I would come into this and I'd be like the youngest person in the room, and now my kid's doing college tours. But the funny thing is, so my wife's got one of these down there, and we're in a competition. And if I just stand here and talk, then it's gonna, she's gonna beat me on steps, and I'm a little competitive. So I'm gonna keep on walking, and I finally got to the point where my kid doesn't, I told her, this is not the one who's gonna go to college soon, but my younger one. If you walk backwards, the steps will go down, right? So yeah, hopefully the one who's gonna go to college doesn't think that. So anyway, so the first thing is that, and the second thing is that the clock that I can actually read is right there. And so I'll be walking around a little bit so I can see the clock, and then I'll be on that side because I can't hear too good, and that's where your questions will come in when you guys ask questions. Anyway, so the net of it is that we've got this separation of concerns that we're going to play through as we go through the talk today. Remember I said that everything that we're doing, we're taking the separation of concerns, and we're going to start talking about what is the best choice to use along the way. And so it used to be that your tool in your toolbox was a SQL database or Informatica or C#. It depended on what your bias was. I grew up as a dev, not as a database guy. Ironically, I spent a lot of time in the database group, as in over 10 years. But I grew up as a dev. And so to me, my natural tool in my toolbox is probably Java. I'll say C# just to be compliant. But if you're a SQL guy, it's probably T-SQL or PL/SQL or whatever your SQL variant preference is, right? Not the type, but only SQL people would get that joke. So today what we have is the ability to have environments where the compute that you use really is much more flexible. If you're a C# guy or a Java guy, then there's lots of ways that you can do things in this space. If you're more of a T-SQL guy, there's also lots of ways that you can do that. If you're a Python guy or an R guy, come on in, right? You've got lots of choice across the tools and how you want to use them. The interesting thing is just understanding when to use which one and why. And so we're going to go along a journey today where we're going to talk a little bit about the different ones and so on and so forth. The other thing I would say here is that there are a set of different scenarios that we've been playing with when it comes to data patterns and so on and so forth in the cloud. And I'm going to be a little bit more honest than maybe some of the organizations would like when I talk about this slide. But the first one is hybrid and DR. And so the idea here is that a lot of people have a data warehouse on premises or have a bunch of ETL processes on premises, and they want to actually replicate those in the cloud. The ideal situation is that we'd have like a great metadata replication system, change data capture so that you can actually move your data up into the cloud and so on and so forth. And it turns out that we're not quite there yet. Those are things that we're working on, but to have like a seamless from SQL on premises to your SQL data warehouse in the cloud, seamlessly integrated stack, we're not quite there yet. And so today, a lot of the hybrid and DR solutions are roll your own in terms of how you do the replication. We do have great tools like Azure Data Factory that allows you to schedule replication from on-prem to the cloud. But to say that we have something like a built-in change data capture solution that allows you to do that, we're not quite there. Lift and shift. One of the guys, when I was showing them the slides, said that you should call this lift and O-shift. Here's what we commonly hear. Hey, I have this awesome solution on premises. It's my storm topology that, I've got Kafka running. I've got all of this data coming in. I've got a storm topology that's doing all this processing, and then I'm landing it into the SQL database, and then I have a set of dashboards that run on top of that SQL database, and it's all, it's all stuff that works in Azure, and so I'm just going to take this and I'm going to deploy it in Azure, and it's going to work great. Or I hear, I've got this amazing 20-plus-year-old SQL data warehouse with millions of lines of stored procedures, and I should just be able to put that up in the cloud and get the magic of elasticity in the cloud to provision more VMs, and things will be great, and I won't have to buy new hardware. And then you get there, and you have the O-shift moment, where all of a sudden you're thinking, OK, well, what does it really mean when I deployed this topology in the cloud? Are the latencies the same? Did it actually scale out like I thought it was going to? Primarily in the SQL database guy who wants to actually provision 10 SQL VMs to do what he thought he was doing in one, and so on and so forth. The IoT space, this is one, like I said, we have a team that's specifically focused on that. Turns out that that's really different as well, because all of a sudden, when we think about IoT, we're thinking about data coming in from a whole bunch of devices. And it's a great story for the cloud, and it's data that's born in the cloud. But the processing considerations that you would use for IoT are different to the processing considerations you would do for doing your month-end batch processing, so that your financial guys or whatever could see it the next day. And finally, the composite. This is where we see most applications landing, right? One of the projects that we've been doing that's pretty cool, you guys have probably seen the ads on TV, is the work that we did with Real Madrid. And that's a classic in terms of a composite scenario. In the Real Madrid scenario, you guys know who Real Madrid is? OK, so you guys actually watch real football then? No. So the cool thing about Real Madrid is what we did with them is we built a phone application, a fan engagement application. And the idea was that people could do stuff on their phone. They could get custom content that they couldn't get elsewhere. And they would have a deeper connection with their club. And so all of a sudden, we can get interactions off the phone. Sounds like an IoT-like scenario. But also, it's tied to CRM. And so we can now look at what kinds of transactions they're doing in the Real Madrid store and so on and so forth. Oh, also, it's tied to social. And so we can get the social exhaust. And so it becomes more about a customer 360 view, where you're getting data off of a device, off of the Twitter fire hose, actually off of pretty much the whole social signal that we can listen to, and also off of traditional transactional data like CRM and so on and so forth. And so all of a sudden, when you think about processing that data, it doesn't fall into one bucket. It's not in the, I can do a month-end batch, or I can do this continuous processing. It's somewhere in between. And you have to use the right tools to be able to satisfy that as well. Again, if you separate concerns and think about how is the data landing, how are you going to do the processing, when are you going to do the processing, and how are you going to serve it up, it makes it easier for you to be able to tackle that problem and understand how you do it. All right, so the first thing is ingestion. Yeah, it's funny. So Lara, when I showed her this slide, laughed her head off. My wife, when I showed her this slide, said, "You're going to show that?" So I kind of liked it because if you think about the cloud and you think about just the whole problem that we have when it comes to getting data into the cloud, it really, to me, just makes the cake. So effectively what happens is if I'm on premises and I'm trying to get that 20-plus-year-old SQL data warehouse and I'm getting all of this data from enterprise systems, then I've got this interesting challenge where I need to beat a batch processing window, but I'm getting all of these very large files at the very end of the month. And so now I have to move my data into the cloud and then start my batch processing window and execute. And so if I had scaled out and managed to save time in the processing, did I save time for total net throughput if I just lost it all on my data movement into the cloud? It becomes an interesting problem. The other side is that if I'm on the IoT side and I'm doing a whole bunch of devices, do I have a model where, like she's backing up right now, right? There's a whole bunch of back pressure on that cake that's saying, you probably need to chew or swallow before we can stuff some more into your mouth, right? And so do I have, her buffered ingestion model is that she stops shoving cake in until she takes the next swallow, right? What is your story when you're in the cloud and you're getting, hundreds of thousands of devices sending data at you? What is your buffered ingestion model so that you can actually back up all of that incoming data so that your processing can catch up with it? One of my teams is an end-to-end team. It's 9 guys, and they have probably the best job in the world. They get to sit down, listen to what customers are doing, then generalize the problem, and then build out the scenario internally as a synthetic workload and try and use it to break Azure. And so, for example, we have an IoT project that we've done where we're deploying it in every single Azure data center, and we're jacking up the number of devices because the devices are synthetic. We have something that runs on Service Fabric that's just a simulator of devices, and so we can go from 0 to plenty devices that are sending telemetry against the system at any time. And what we do in that end-to-end team is we actually take we instrument the heck, that's an appropriate word, right? We instrument the heck out of the app, take all that log telemetry, and literally we're trying to break Azure. And so one of the big things that we do is we replicate the scenario, but then one of our key solutions is a solution much like what we're talking about, which is taking that data and then doing analytics on it so that we can see in real time what's going on in Azure, but then we can also look back and forward at what's going on. So we can take historical and see trends, but we can also do machine learning so that we can start getting predictive analytics on when we think something's going to go bad. Interesting thing about that is that we generate about 12 terabytes of log data a week. The other day, and we shove a bunch of that, we used to shove a bunch of that directly into an Elasticsearch cluster. And we did that because the first thing that we wanted was the operational dashboards. And so we indexed, we prioritized getting this data, the log data, into an Elasticsearch cluster so that we could get a very fast index, and we could stand up Kibana so that we could do operational dashboards on top of this. Well, turns out one day, we had a little situation. The cluster went down for about 8 hours. It wasn't Azure. It was our fault, but we don't like to say that. Now, we didn't lose any data for those 8 hours because the telemetry data isn't going straight into Elasticsearch. It's going into a broker. It's going into event hubs. And by writing into event hubs, we actually have that buffered ingestion spot. So once we got the cluster back up and healthy, we just kept on reading off of event hubs, and we were fine. That's the notion of buffered ingestion. So when we think about ingestion, we really tackle it in two cases. Kind of the batch thing where we'd use something like Azure Data Factory to upload the data. That would be kind of like, she shows up at the table once a day. There's a cake. There's a finite amount of food that she can fit in her mouth. She puts it in her mouth. She leaves. In this case, we're doing the buffered ingestion, which is hammered. And at some point, that back pressure comes up. Hey, we're not swallowing anymore. And she's got to be able to hold that, right? And that's event hubs. And so, in Azure, the great thing about Azure is that there are many options. You don't actually have to use event hubs. We like to use event hubs. It's a PaaS offering. The HD Insight team is working on a PaaS version of Kafka. I'm looking at him because I believe I'm allowed to say that. You did now. Yeah. Yeah. See, this is why I don't come to these things. I'm always afraid that I'm going to say something and get fired. So anyway, the thing is, whether you're using Kafka on IaaS, Kafka on HDI, if that may or may not ever happen, depends on whether I'm allowed to disclose that or not, or you're using event hubs, the idea is that you're using a buffered ingestion point so that as your data comes in, you're not losing it if your processing can't keep up. It's also great if you're doing processing and you have spikes. Imagine that, true story. We're working with Real Madrid, and Cristiano Ronaldo. Everybody knows Cristiano Ronaldo, right? Arguably the second best player in the world. Okay. So Cristiano Ronaldo retweets a picture of Gareth Bale, where Gareth Bale had sent a picture of him with some product that he was about to start endorsing, and it went viral, okay? And all of a sudden, they're getting way more tweets for hashtag Ronaldo than they had for the month or two that the system had been up, okay? Great example of how these types of solutions can catch up, because all of a sudden you got a spike in processing because the traffic's gone up, right? But even though you've got a spike in processing, you don't necessarily have to go spend the burn of growing out elastically to do the processing, because you have a buffered ingestion case. If you don't need that data processed in the same time as you normally process it, if you can catch up, then you don't need to scale out your topology, in this case a storm topology. You can just keep on processing at the same burn, right? And then as that comes down, you're just going to burn through what's been in your broker, right? Now, the other interesting thing about this that I should say is, and we'll get to this when we talk about processing, is that the reason that we use a message broker is so that you can use multiple processing instances against it. So I could actually have, say, event hubs that I've stood up, and I could have a storm topology that's doing some processing on the events that are coming in. I could have a Azure Stream Analytics deployment that's doing processing on the same events. And I could also have some logic and service fabric that's getting data off of event hubs and processing at the same time, right? The nice thing about a broker is that it gives you the buffered ingestion, right? It also gives you the ability to have flexibility in terms of number of consumers and types of consumers on the other end, right? One of the big things that we think about when we think about ingestion and data movement in the cloud is having the model where you can actually have the data going into a case where you have that flexibility. When we often do the batch processing, we're pushing the data into storage. And the reason we push the data into storage is because you can do the same thing. In the cloud, where you have disaggregated storage, i.e. your storage is separate from your compute, you can actually now start processing using multiple different types of compute over the same storage. So whether you use a broker or whether you use storage, you get that flexibility. So this is figuratively what we were just talking about. You can have multiple event streams that come in, they get pushed to a broker for further processing. For SQL people out there, I like to say, just think about the broker as a log that you are processing against. Or the other way is that you just push against the store, and you push into storage, and then you can do multiple types of processing on top of that. All right, staging. Remember I said that the logical flow was different to the actual flow? So when we talk about the logical flow, we talk about ingestion, processing, staging, and serving, right? But when you think about it from a decomposition of the different stages that you're going to do and a separation of concerns, it turns out that staging happens all over the place. For example, when I write data into the event hubs because I'm getting data from multiple devices or I'm replaying data from an on-prem system into the cloud, by pushing it into event hubs, I'm actually staging it. Because what I have is a durable log that I can actually start building data on top of. So that's a notion of staging data that is either streaming data or continuous data, if you will. If I put data into Blob Store, because it was my first thing that I did as part of ingestion, it's also staging it, because it's the first place where I can consume it and start processing it in the cloud. And so even though we think about separating these things, it turns out that the first side effect of ingestion is that you've immediately staged your data so that you can do processing on it, if that makes sense. So in this case, what you're seeing is that it's the same thing. I brought my data in, it hits a broker, and then I can actually have multiple types of compute on top of that. And the fact that I can use the multiple types of compute on top of the broker is because the data has been staged in the broker. Now, one of the interesting things that we do, and we'll talk about this as we go to processing, is you can then process out of the broker, and then you can push that into another broker, or you can push it into a queue, which means that you can keep the data moving along. And so as the data is being processed, it moves along in flight to your quote-unquote endpoint. And so staging does not have to be a terminal point. Staging of data is literally just getting to the data to a place where you can do some processing on it. On the bottom of the slide, what we have is, like I said, just putting it into blob storage. Now, I say blob storage. I'm going to use that as a moniker for either using blob storage or Azure Data Lake Store. As we get to the end of the slides, I will get a little bit more specific, and I will actually talk about ADLS as a store. But right now, what I'm trying to do is be a little bit more agnostic and just say that we're in storage, okay? And so that's how we do staging. All right, processing. So at the end of the day, data is staged for one of two reasons. Data is staged because it's the point where you're going to prepare to serve data to others, or data is staged because you want to do some processing on it. Theoretically, there's a third, which is that you just want to keep the data around. I mean, the idea of a data lake, if I go to the kind of pedantic analyst type representation of a data lake, is all of the above. A data lake is the place where you rendezvous data of multiple types, multiple forms, in a single place where you can do multiple types of processing on top of it, and where that data can stay around forever. And there's assertion there that that data in that data lake is backed by cheap, reliable storage, i.e., it's reliable, so you can put it there and you'll never lose it, and it's cheap, which means you can put a whole bunch of it there, right? And so a lot of the things around data lake scenarios is about making sure that the cost of storage starts going down so that you can scale to as big data as you want. But the other side of it is that as that data gets there, you need to be able to have tiered notions so that you can have fast access to hot data, but the data that is around for a very long time should still be accessible even if it's at a cheaper price point and a lower performance price point. So in Azure, when it comes to this type of data, there are many types of ways to do processing. We're going to talk over the next couple slides about how to think about processing in this model. So the first thing that I like to talk to people about is bounded versus unbounded processing. So the reason I use bounded versus unbounded is because a lot of people immediately go to the word streaming. And as soon as you go to the word streaming, you start thinking that I need a stream processor, or you think that I need to do complex event processing, or blah, 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 and you overcomplicate the solution. What I would like to do is get the world to liberate their minds from the notion of streaming and batch, and just say, are you going to do, are we being filmed? Are you going to do work on this bottle of water right here, where this is all of the water that you're working on? Or are you going to do work on the water as it comes through like that, right? Where you don't know when the bottle's going to empty. In the first case, don't walk there. In the first case, when the water's in the bottle, you're going, yep, that's what I'm going to do. I'm going to process the data that's right here. In this case, you're building a system where you don't know when that bottle's going to empty. In fact, you don't know if it's a bottle that's pushing the water or a fire hose where it's just coming through, right? That's the difference between bounded and unbounded processing. Now, the traditional batch systems are bounded processing. That's why that 20-plus-year-old system that I just talked about, why they talk about a batch window, right? They're trying to get to a world where they can go from 14 hours to 10 hours in terms of processing, because what they want to do is help their analysts who are getting that data see that data quicker. And what we're saying to them is, hey, that's great. Let's do that as step one. But imagine if you could, instead of doing a batch window, you could do a continuous processing window. One drop. There are more bottles under here. I could actually go to town on that. Let's really talk about streaming. No. So the idea is they're trying to go from 14 hours to 10 hours. And I'm saying to them, hey, look, if we could start just working upstream, like a lot of your data comes from SAP, and the only reason you get it at the end of the month is that's the only time you get the extract. What if we moved upstream and we got that data earlier? Like, even if it's just hourly. Imagine if I could just get that data hourly. I don't know how much I'm going to get every hour, but whatever you give me, I'm just going to process. And oh, by the way, a whole bunch of your data comes from Dynamics. Gee, sounds like we know those guys. They work, they're part of our company. We should be able to speak to them about how we get that data in a continuous mode. And so then all of a sudden, instead of having a 14 to 10-hour process, what if we could say that we could get you your insights at any time where it's within an hour of accuracy? Why can't we get that to when it's within a few minutes of accuracy, right? Well, it turns out at that point, it's not a technology problem anymore for us, right? We'll show you the different types of solutions that we use, but it truly is not a technology problem anymore. What it becomes is a business process and compliance problem, because the way that data lands and how it becomes available for processing really depends on how far upstream you can go to change the legacy systems where you're getting the data. That's the thing I love about IoT. It's a green field, right? No offense to people who are not working on IoT projects, but it's awesome because we can get that data in and we can do the continuous processing. It's a lot harder in these types of systems where we actually have to swim upstream, try and get the data, and get it in a more continuous way. But if you think about it as bounded versus unbounded, it changes how you actually design your solution. Somewhere this is a clicker, yeah. All right, batch processing. So in Azure, the canonical way to do batch processing today is it depends, actually. So I just showed it over there, HD Insight. So if you're thinking about batch processing from a big data perspective, the canonical way to do it in Azure today is HD Insight. If you're thinking about it from a relational way, the canonical way to do it is SQL. A lot of the stuff that we see in the lift and O-shift model, because it's come from more of a traditional legacy way, comes in from SQL. And then we start talking about whether SQL is the right thing to use anymore. A lot of the more modern, and I hate to say that SQL doesn't sound modern, but a lot of the more modern approaches in terms of that are being moved to the cloud often have already started playing with something like HD Insight. Step one, obviously, is that you have your data staged. In our case, that typically means that you have it in blob storage. It could also mean that you already have it in a SQL database in the cloud. Step two is that you choose the compute model that's appropriate for you. In HDI, there's lots of options. If you're doing a data flow type thing, you can use Pig. If you're a SQL type developer, you could use something like Uzi and coordinate a set of SQL of Hive jobs. You could use Azure Data Lake Analytics and use SQL. That's the right public term, just making sure. To do the same kinds of operations on top of the data. There are multiple types. There are multiple options. I'm going to share with you, and this is not benchmarking or anything, but this was an interesting exercise that we were doing that will help you consider how to do your batch stuff. When we were doing the work with that 20-plus-year-old thing, we took a set of the stored procedures and we moved it into the cloud. And we started exploring different solutions for it. It turned out that as we looked at the data in that solution, as we looked at the logic in the solution, most of what was being done was point lookups. So they had these massive queries in stored procedures that were doing these crazy left outer join this and blah, blah, blah. And when you looked at it, what they were doing is they had dimension tables that they were looking up values in so that they could create the next entry that was going to go into a fact table. And so we could decompose that into lookup, 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 right. And so when we looked at our options for that, in a batch case, the first most logical way is to say, you got a bunch of SQL, I'm going to port that, it's going to be SQL, I can port that to USQL, I can port that to Hive, I can port that to whatever, I'm going to go execute on it. But when we looked at that and we looked at the lookups and the frequency of this, in the throughput, the net throughput they do in that database, that massive database that I said on premises, is about 150,000 transactions per second. And we looked at it and we looked at the I/O profile and we realized that a lot of this was pulling from doing these lookups. And we went, hey, a lot of your cost is in I/O. And since you're I/O heavy, if we're going to use a big data solution, it would be nifty if we could cache that in memory. So what we did was we played with Spark. In all transparency here, what we actually did was we used Spark on IaaS because we were looking to use the G5 SKUs in Azure. So we had an 8-node Spark cluster on G5. And the reason that we used the G5s was that there is multiple terabytes of data, reference data, that has to be looked up in order to build this, that becomes the corpus that you do the lookups on so that you can create the fact table. And what we wanted to do was do that as efficiently as possible, which is pin it in memory. So if you guys haven't used Spark, one of the nice things about Spark is that it allows you to create what's now called a data frame, which is an in-memory cache, effectively, of your representative data. And so what we did was we pulled in all the reference data, kept it in memory, and then we'd process through that. And so on an 8-node G5 cluster, we were able to burn through about 500,000 rows per second. On SQL, they were scaling up and getting to 150,000 rows per second. Now, I'm not telling you exactly configurations, because like I said, this is not a benchmark. It's just to show you that by choosing the right tool for the type of scenario that you're using, you can get a significant difference in performance. If it's something where I/O is the issue and you can pin in memory and you can cycle in memory, and wait till I tell you about the continuous processing numbers, then all of a sudden you can kill it because you've removed a bunch of your bottleneck. Similarly, we did another experiment on USQL, not for the same stored procedure, but there was a write-heavy scenario in the workload. And what we did was we used USQL on Azure Data Lake Analytics. And by using USQL, we were able to get significantly faster performance than SQL Server. Now, it was interesting because this was the big challenge that we had here was that we were doing writes. And by scaling out the writes across multiple nodes, like a significant amount of nodes on an ADLA cluster, we were able to just go so embarrassingly parallel in the writes that we were able to optimize the scenario over what you could do in SQL. There are many other scenarios where if you look at SQL, it will be more efficient. And the reason it will be more efficient is just because of the query optimizer. But if you can decompose your workload and figure out where are the bottlenecks and what you want to optimize for, all of a sudden you can choose the right solution. OK. Micro-batch and streaming. So like I said, think about it as bounded versus unbounded processing. One of the big things that we see in the space is that there's not a big difference between micro-batch and streaming. The two major options that people use on the platform, on Azure, are Azure Stream Analytics and Storm. You can use a Storm topology and do a bunch of streaming. But it turns out there's a nifty alternative, and it's using Service Fabric. So one of the nice things about Service Fabric is I can write an app in Service Fabric, and I can deploy it across a bunch of nodes. I can consume data from event hubs. I can do the processing, and then I can push the data back to another event hubs instance. I can push it to storage. I can do whatever I want. One of the things that we did in this experiment where we were porting this business logic was we wanted to think about what this would look like from a continuous processing perspective. So imagine that you had the same 20-plus-year-old system. We took that system, and we said, hey, what we're going to do is we're going to take the data, all that reference data that we're talking about, and we chose two ways to save it so that we could use it for lookups for Service Fabric. The first way we did it was we put it in Redis. Seemed logical. I can actually just do straight lookups from Redis. It scales well. It compresses well. Keep it in memory. Away we go. The second thing that we did was we used reliable collection on Service Fabric. If people have used Service Fabric, reliable collection allows you to keep the data in memory, allows you to replicate the data across nodes. So it's a nifty way to keep your data available as a cache in memory. What we found was that obviously you pay some cost. It's funny. I guess Mark Russinovich probably did a talk, and maybe he did something on Service Fabric this time. I was on an email thread with him when we showed him the Redis numbers, and he kept on saying, why did you use Redis? And I knew what he was asking, which is really, why didn't you use reliable collection? And I knew why he wanted us to use reliable collection was because it's in mem. But the thing was, when we were doing the experiment, the easiest thing to do was get the data into Redis to start. And so I kept on saying, well, it was the first thing that we're doing. It's easy. And it's one of those emails where email threads where it's going, and you realize that what he's really saying to you is wrong answer. But you keep on going. And he's awesome about it. He's a great guy and all. But the reality was we did it with Redis. And on a single node processing, like I think it was a D3, processing a single node, we could blow out the processing pretty significantly. Where we got bound was we were network bound in terms of the I/O for the rate of lookups that we were doing on against Redis. When we moved that to reliable collection and started processing it there, I think we ended up like 200,000 transactions per second on a single node, single D3. Remember that we did 500,000 on 8 G5s. And we looked at it, and we started scaling out, and we went, oh, gee, look at that. We can actually process a whole bunch of this. And oh, by the way, we were barely pushing any CPU load when we did that. Because, and Christian Martinez, who's a guy on our team, he likes to say, there's a whole bunch of these ETL jobs that are just ETL lookups in a for loop. And the funny thing is, if you can decompose the problem and capture it that way, it becomes very, very efficient and and it becomes embarrassingly parallel for a lot of these workloads. And so if you can get that density on a single node, and then it scales well. Obviously, never scales linearly, but approaches linear scale across nodes, all of a sudden there's a very different way to view the problem. Now, why would I care about throughput if I'm doing continuous processing? So if I'm doing continuous processing, my argument is I don't need to worry about a batch window because I'm going to get data all the time. But the problem is all of these business systems still have an SLA. And so remember that I said that one of the big things is that you have a buffered ingestion in case something goes wrong. And then when something does go wrong, you want to be able to catch up by consuming what's in the buffered ingestion. And so even if I had built a system that was a streaming solution where it caps out at, say, 1,000 transformations a second instead of 200,000, and let's say that something, somebody made a config change that we didn't understand because that never happens, and your system's down for 24 hours, when you bring it back up and you've got all of that transaction data, that sniffs like a batch window. And can you scale that out? Can you actually grow your system to make it more parallel and process more in parallel so that you can actually catch up and still stay within your SLA? And so it's very important when you think about these batch solutions that you think about not just the throughput in the happy case, but the throughput in the failure case where you actually have to be able to, quote unquote, catch up, if that makes sense. I think I told Lara that the problem is that I'll just talk and talk and talk, and maybe I'm doing that. So that's basically what we were just talking about, the processing thing. Maybe I should have been on this slide while I was talking. So serving, we've only got like 7 minutes left, so I'm going to go a little bit quicker on serving and then open up for questions. So on the serving side, I mentioned to you that one of the challenges with serving is that you have to actually think about the scenario. We've broken the scenario down into 3 typical cases: dashboards, interactive, and exploration. When I think about dashboards and interactive, I typically think about the fact that I need a fast response time. Now, one of the things that we've seen with people and Azure SQL Data Warehouse, Azure Data Warehouse, whatever the right name is that as soon as they start using Azure Data Warehouse, they're happy. They've got large data in it. They can express queries. They get the queries back in a reasonable time. And so one of the most common things we hear is, great, this sounds like my scale-out version of a BI product. I'm going to throw a dashboard on top of it. And yeah, you're using a column store technology, very much like most BI technologies do. You don't have the same level of pre-aggregation and in-memory caching that you have in a BI tool. And oh, by the way, in Azure Data Warehouse, there's a query queue because it's a data warehouse. It's meant for making big queries possible. It's not meant for doing high concurrency small queries to satisfy dashboards. And so the first thing that people often hit is that I believe it's a 64 current query queue. So if you've got a whole bunch of complex dashboards that are running, tens of queries against your single SQL data warehouse, and you've got multiple people doing that, all of a sudden, boom. Guess what happened? You hit your concurrent queue, people are blocked, they're waiting for queries to process before they can come in, and your dashboard response time gets kind of slow. For a lot of the cases where people are doing high concurrent queries for dashboards, we look at a couple different types of solutions. The first one is analysis services. Analysis services in the cloud on IaaS is something that we do a fair bit for this scenario. Because what we'll do is we'll put the data into the staging layer, i.e. blobs or SQL. We'll do processing and process out of that into AS and still use AS as a serving environment for our dashboards. For log data, I mentioned Elasticsearch. It's still one of the most common things that we use, where what we'll do is we'll put data into Elasticsearch. Within Elasticsearch, you get an inverted index. It's a very fast index build. And you can use things like Kibana on top of that gives you a great dashboarding experience. It really is optimized for things like the operational dashboard type of view as opposed to, say, a business dashboard, but it's a great experience. Another thing on the operation dashboard case that we've been using a lot recently is Redash, which is an open source dashboarding experience on top of Spark, which does output caching and Redis. It's very, very cool. And so if you're using Spark on top of your data lake, then it becomes an interesting scenario. The other side of this is when you're not looking at more of an operational dashboard. What you're really looking at is being able to have longer running experiences over your data. And so the cases that we often see for this nowadays, the canonical case for this nowadays is your data scientist. Imagine the data scientist who, woe is the data scientist who can only use the data from last month because that's the only data he has access to or the only data that he can process. We had one customer that was using an MPP data warehouse, a parallel data warehouse on premises with tens of terabytes of data for their data processing. Because what they needed to do, and these were data scientists, what they needed to do was all of the sampling, everything very efficiently to get to that final data set they cared about that they could build a model on. And if they use just a single relational store, or if they used a big data store, they weren't getting the efficiencies that they were getting across a parallel solution. What we've been experimenting with them on is using Spark to do the same type of interactive queries over very large data sets in the cloud, and also using USQL to give them, again, things like USQL are great because what they do is they give you the ability to do that processing across that very large data set very efficiently to sample down to get the sample that you'll build a model on top of. And so one of the things that we like to see on the data science side is that what you would do is you would stand up your data in your data lake, so Azure Data Lake service. And then what you would do is you could choose to use ADLA, which is the analytics piece with USQL to do that type of explorative process queries on top of it. Or you could stand up something like HDI and do processing on top of it there. The nice thing about ADL, Azure Data Lake, is that it's actually, again, another separation of concerns. You have the compute layer, ADLA, that gives you the query experiences with things like USQL. And then you have ADLS, the storage, that gives you the infinitely scalable data lake experience. The big thing about ADLS that is promising for us is the fact that today with blob storage, the canonical experience is that you string together a whole set of storage accounts. And this is to get around throttling, this is to get around size limits and stuff like that, where you get a bunch of storage accounts and then you use these and bind them to whatever your compute infrastructure is. With ADLA, you can think of this as a higher level service that abstracts away the need to do any of these multiple storage accounts. ADLS, sorry, I always get these things mixed up. Words are not my forte, or letters. So you string together, imagine that it's a higher level service so that you don't have to string together these storage accounts. What you can do is just put your data in it, it gives you the scale, lets you then use that as the place, as your staging layer that you can do the processing on top of. Right, so I'm a little over, so I'm just gonna say, we did kind of a fast pass through a bunch of different things. The idea here is that in Azure, you've got the tools, if you think about this from a separation of concerns perspective. Think about your ingestion, think about your staging. Use things like SQL DW for your scale-out relational workloads. I like to think about using things like ADLA and Spark more for our high-throughput ETL workloads. I also like to think about using things like ADLA and Spark for a lot of the data science workloads and for the exploratory workloads. But then when it comes to general serving, we still tend to push to SQL DW or SQL Server, depending on the scenario. One of the big reasons that we still push to SQL is a lot of the times in the serving case, the consumption end of that tends to be tools that work well with SQL. The other side is that a lot of environments today, from a compliance perspective, SQL becomes the better answer. I can actually use my policies around row and column of security, on audit logs, around encryption at rest, and so on and so forth. And so for a lot of environments, what you find is that ADLA and ADLS become the general sandbox for your processing. It becomes your processing environment and your staging environment. And then SQL becomes your serving environment and your compliance environment, if you will. And so with that, I think I've hit 0. I apologize for the fast pass through. Hopefully I could stay for a few questions before they kick me out.